Hello all, I am Ayushman on behalf of Team FunnyCast, explaining to you our problem statement. We were working on problem statement 06, which was building a tool chain to simulate Anycast flipping and how it affects CDN based user performance, especially on web vitals like FCP. So let's go through our architecture on how we are implementing the problem statement. Uh, this we are doing this using Docker containerization. What we have here is a client namespace which is connected to router, and router in turn is connected to node A and node B. We are using FRR routing services, that's fast routing algorithms, and we put BGP into use in this router namespace. The node A is then connected to an Anycast IP, that is 10.0.0.100, and the same IP here. These both uh, advertises the same IP to this BGP, and in turn, this router selects the best preferable route to access this web page. Now we have this Anycast manager.sh which continuously checks health of node A and node B, and based on health and latency, it tells Anycast to flip the routing services. Now, how we are doing this routing services is using local preferences in this router configuration. So once if it tells us to flip to node A, then our local preference shifts to node A and hence this route is selected. Let's check the working prototype. Here we are running the command docker execute it router vtysh. Vtysh is the shell provided by FRR routing. So if I write show IP BGP, then we can clearly see the next hops are 10.0.3.2 and 10.0.2.2 for the same network, which is our Anycast network. If we look into our networking namespaces, then you will find that 2.2 was for node A and 3.2 was for node B. Okay, now let's look at the Anycast manager. So now uh, this continuously checks both the nodes. See, currently the local preference of node A was 200, node B was 100. So it continuously checks whether node A is reachable or not. Once let's say I disable node A or make node A unreachable by the router, then what will happen is this thing will shift its whole route to the new route, that is node B with local preference 200, and now it will continuously check node B. If I restart node A, then it will again shift its preferred path, which is the best path according to the BGP, to node A. So this is how we are implementing flipping, and this exactly is how we are implementing our Anycast network. This is the other way in which we are implementing Mahi Mahi into our workflows. So here what we do is we set up two Mahi Mahi shells, shell 1 and shell 2 in this particular port numbers, IP addresses, and we put a delay of 30 milliseconds into shell 1 and a delay of 80 milliseconds into shell 2. These shells in turn host two Nginx servers, one each having uh, a port 8443, which is capable of sharing or fetching both HTTP 1.1 and HTTP 2 addresses. We have a mock web page having images, CSS, JavaScript, which will be fetched into this server. Now we have a test proxy.py that continuously requests for this web page. These requests are forwarded to flipproxy.py, which is probabilistically flipping between the backends. And currently we have a probability of 3.2%. So approximately out of every 100 requests, 97 will go to the lower latency and 3 would move to a higher latency. Now this, whatever the matrix is we get from this web page is transferred to testproxy.py, and by using Puppeteer into this JavaScript model, we are fetching all the performance matrices from this web page and putting it into a CSV. Now this CSV file goes on to an analyzer which analyzes the differences between HTTP 1.1 and in HTTP 2 in this flipping environment. So let's check the demo of that. Here I have a delay shell of 30 ms and I am hosting my uh, low latency server. Here I have a delay of 80 milliseconds and I am hosting my high latency server. So let's check in this reverse proxy if I hit enter. Yeah. So it now starts calculating. This is the protocol H1.1. Currently the number of requests is set to 20. So I'll pause the video and let's move on till we get to HTTP 2 protocol. Yeah, so as you can see, we have generated these logs into a CSV file where, according to a protocol, it automatically saves the analysis or the results that it fetched. If I run I analyze web vitals.py on over this, so it creates graphs using matplotlib and pandas. So these are the graphs that are generated. The analysis and the results and observations of this graph has been clearly mentioned in our documentations and GitHub readmes. So you may refer to that. Thank you.